Alright, welcome back. So today we're going to be looking at solution stoichiometry and kind of ending off the different types of stoichiometry that we can possibly get questions for. So you will notice that it's going to be very similar to the other ones that we've done so far. The only difference is right now we are going to be dealing with stuff in solution. So that's where our concentration equations are going to come in. So of course, for these right here, you will notice that the process for solving them is going to be the exact same that we've seen in the past. The only difference is going to be equation 2 and equation 4. So, of course, our first step is going to be write the balanced chemical equation for the reaction. So that's not going to be any different. Now with these here, because we're going to be dealing with stuff in solution, you will need to use the solubility chart to figure out if a precipitate is going to form, because a lot of questions kind of will be based on that. Now step 2 is going to be determine the molar amount given. So number of moles can be volume times concentration, or if you're given a mass, we can get number of moles is equal to mass divided by molar mass. And of course from our last one, we can get number of moles is equal to V over Vm, or we can be asked for number of moles is equal to PV over RT. So basically we can be asked to solve for any of these here, and it all depends on what we're given. So if we're given a concentration of volume, we're going to use this. If we're given anything else, we use a combination of these equations. Now step 3, determine the number of moles of our required substance or our wanted substance. So this is going to be the same as always, where we take number of moles of our wanted is just the number of moles are given times our mole ratio. And remember, mole ratio is coefficient of our wanted over the coefficient of our given. And then of course step 4 is going to be solve using the appropriate equation. So we can be asked to solve for volume, we can be asked to solve for concentration, we can be asked to solve for mass, we can be asked to solve for pressure, volume. So it just comes down to what we are asked. So that's why it says a little note right here, there may be a combination of different stoichiometries present. So just make sure to read the question carefully, and of course make sure to pair all values with the appropriate things inside of that question. So let's look at our first example, where it says 100 milliliters of a 2.00 moles per liter of hydrogen sulfate solution is spilled on the floor. So the teacher grabs a 0.500 moles per liter solution of potassium hydroxide and pours it to neutralize the acid. So what volume of solution must the teacher use? So for this right here, even before I get started, I just kind of like to go through and make little notes on specifically things that aren't in the right unit. So I know because we're dealing with concentrations and I can see concentrations here, I want to convert this into liters because we're given milliliters. So just remember, in order to go from milliliters to liters, we divide by 1,000. So 100 milliliters should be 0.100 liters. And that's kind of the only conversion I need in this particular equation, because we have 2 moles per liter, cool, and 0.5 moles per liter, even better. So our first step, step number 1. Balanced chemical equation. So we have the hydrogen sulfate solution. Now, of course, remember, hydrogen sulfate, all hydrogen containing compounds, we treat them like ionic. So sulfate is SO4 2-, hydrogen is H1+. So we do our drop and swap and we're left with H2SO4. So that is what was spilled on the floor. It is going to react with potassium hydroxide. So potassium hydroxide is KOH. So this is a double replacement reaction, or as you'll see, this is an acid, also known as sulfuric acid, reacting with this. So it is a double replacement reaction where we're going to get potassium sulfate and water, because that's H and OH. And of course to balance, 2 in front of there, and a 2 in front of there. Now potassium sulfate, I am going to have to check the solubility of this one, just kind of make sure. Now this right here, because we don't really need to know anything about potassium sulfate, but it is a very good habit to get into, just checking our solubility charts, checking sulfate here, knowing that most things are here. The only exception, calcium, strontium, barium, silver, mercury, lead, and radium. So that means potassium is right here, which makes it very soluble. So we can write AQ. Just a good habit to get into. Now I'm also going to highlight my wanted and my given. So we have 0.1 liters of 2 moles per liter. So we have two values for our hydrogen sulfate. So that means this is our given. And what volume of potassium hydroxide must be poured onto that solution? The potassium hydroxide is my wanted. So that kind of clarifies things when I go to step 2. So number of moles, I'm given volume and concentration. So number of moles my given is C times V. So the concentration is 2.00 moles per liter. The volume is 0.100 liters. And we get 0.200 moles. Our third step, number of moles were wanted. This one never changes for stoichiometry. We take the number of moles that are given and we multiply by our mole ratio. So number of moles are given, we just solve for 0.0200 moles. Our mole ratio is the coefficient of our wanted, which is 2, over the coefficient of our given, 1. And now we get 0.400 mole. And finally, last step, step 4, solve the question. And this one says what volume of solution must be used. So that means we're using the concentration, volume, and number of moles equation just rearranged. And of course, this one rearranged, volume is equal to number of moles divided by concentration. So we get our 0.400 moles divided by the concentration, which we have up above there is 0.500 moles per liter. And of course, when we do this one, we get a value of 0.800 liters or 800 milliliters. Both answers will be acceptable. And that is how we use solution stoichiometry to solve our problems. Now, if you've been keeping up on the workbook and a lot of the stoichiometries, you'll notice that this is kind of getting very similar between all of them. And that is true. A lot of the stoichiometries are like that. The only difference are the equations we use based on step number 2, so getting the number of moles of our given, and step number 4, solving the question. So, what I would like for you guys to do is pause the video and see if you can get example 2 on your own. And I'm going to put up the answer in about 3 seconds. And when you do it out, you should get an answer that looks like this. So of course, our balanced chemical equation, we have potassium nitride reacting with calcium sulfide, and that is the reaction right here. So potassium sulfide mixing potassium nitride, and we produce our potassium sulfide and our calcium nitride. So of course, once you get your balanced chemical reaction, it should look like that. Number of moles of the given is C times V. Number of moles of our wanted is number of moles of our given times our mole ratio. And of course, solving what volume must be reacted. Volume is just equal to N over C, and we get 2 liters. So that is kind of it for the solution stoichiometry. Like I said, very similar to all the other ones, just equation 2 and 4 are going to be different in those steps anyway. So our last lesson for this week, we're going to be looking at predicted and experimental yield. So it's going to be very similar to percent difference in a sense of this is just a way to check our reactions to make sure we're doing them right. Of course, if we actually had a chance to do a lab, but we'll just kind of look at that now at the next lesson. That'll be it for this week. So make sure to work on your workbooks with the solution stoichiometry stuff, and I'll see you guys for the next lesson on predicted and experimental yield.